All right, let's take a look at your next lesson on similar figures. We did congruent figures last time. Let's take a look at the learning goal. Learning goal today is number 46. I will be able to use proportions to find missing lengths in similar figures. So you can fill out 46 for the learning goal for similar figures. All right, let's go down in the page sorter and take a look at today's notes. All right, so similar figures. We're going to be talking about the difference between similar figures and congruent figures. Remember, these are congruent figures above, same sides and angles. Okay. The difference with this is similar figures do have the same angles, but they don't have the same side length. Okay, but that means that they're proportional. So let's go ahead and write that down. They have congruent angles, and their sides are proportional. Okay, and so you can see if we look at these shapes down here, these angles are all the same as over here, but the side lengths are different. Okay, so that's what we're going to be working with today. You can use those ratios that exist in one shape to solve for missing sides in the other because they are proportional to each other. So we have already done the symbol for congruent. The symbol for similar, you just remove the equal sign and you just have that tilde, which is going to represent similar. Two ways to find missing sides. You can identify what the scale factor is, meaning what are they multiplying to go from this number to this number, or you can set up a proportion and solve for x, whatever variable you chose. All right, so let's go ahead and walk through this. First section is going to be focusing on scale factor. They want us to name both of the similar figures. With our work done before, you know that the order matters. So I'm just going to start in this top right angle corner, and I'm going to go D, E, F, and G. Okay, and so for this one, I have, let's see, quadrilateral, D, E, F, G, and it is similar to quadrilateral, and we need to go the same order. So I'm going to go L, M, N, O. L, M, N, O. Okay, so we have those two similar figures there. They're telling us to circle side DG and its corresponding side. So when they say corresponding, they just mean what is the side that matches with that, that is similar to it, okay, or proportional to it. So circle side DG, I'll use a different color here. So here's side DG, and we just identify and find that same side up there, okay? So we've done that. So we have DG and LO if we're going the same direction. All right, so scale factor, okay? We're looking at side DG that we've already circled here, and we're wondering what the scale factor is from side DG to side LO, okay? And so let's go ahead and mark LO. And so we have side DG to side LO, and that scale factor, if you look, remember they're just saying what are you multiplying by to get from 6 to 12, and we can see that we're multiplying by 2. Okay, and so the scale factor equals 2. Okay, they want us to box side EF and its corresponding side, so go ahead and take a look at EF. So here's EF. Oh, they want us to box it though. Box EF, and it is corresponding to MN. Okay, and then the last one, use a scale factor to find the value of X. So if we're comparing from 10 to here. We know the scale factor from the one quadrilateral to the other is times 2. And so obviously x is going to be 20. And so we can show our work and just say 10 times 2 equals 20 and circle our answer. All right, this next section, we're going to find the length of a side using indirect measurement. Okay, and so basically that just means creating a proportion to solve. Okay, so name the similar figures. We can pick any order we want. I'm just going to start at the one that is most obvious to me, which is that one that sort of looks like a 90-degree angle. So I'm going to start at A, and I identify D as the corresponding angle, and I'm going to go to here, which would also mean, let's see, we're going up the short side, down the long one. Okay, and so we say triangle A, C, B is similar to triangle D, F, E. Okay, and so the order matters. You do need to list them in the same order when you're naming them. Circle 2 corresponding sides that have numbers on them. They just don't want us to pick the variable. So we can say the corresponding side with this little 6 here matches over here with this 14 and 4/10. Okay. What is the ratio of those corresponding sides? So I can just say, well, from small to big, it is a 6 to 14.4 ratio. Okay. So if you have a side of 6, then the other corresponding side is 14.4. Find the side with C and box the C and its corresponding side. Let's go ahead and pick a different color here. We're going to box this C here, and then we need to find the side that corresponds to it, and it's over here, 28.8. Okay. Set up and solve a proportion to find the value of C. Okay. So there's a lot of ways to create this proportion. I don't know, I just like to look at the ratio that exists on one shape and then compare it to the corresponding ratio in the other shape. It's personal preference of mine, so that's what I'm going to do. So I'm going to look at this shape right here that has all the information, and I'm going to be going from this shape to this shape. And so I see my corresponding sort of ratios here of, actually I'll color code them so you can see, 14.4 to 28.8 is equivalent to this other ratio. So I'm picking its corresponding side, 6, and then we have C. Okay, and so you can see my ratio matches. I chose the same sides from one shape, and I'm making it equivalent to the same size as the other since they are proportional to each other. All right, and then we're going to go ahead and cross multiply. I'm always going to do the one with the variable first, personal preference again, and I get 14.4C equals 6 times 28.8. So we'll bring out the calculator here. And we get 172.8. We know that we need to divide both sides by 14.4. And we're going to be left with whatever C is because those sides are proportional to each other. So we have our 172.8 divided by 14.4, and we end up with 12. Okay, and so the value of C is 12. Okay, all right. Last one is a very common shadow problem that you find with proportion problems. You don't have to draw pictures typically, but let's go ahead and draw a picture for this one anyway. And so I have a 5-foot person standing near a tree. They both have a shadow. One of the lengths, either the shadow or the height, are going to be missing, and you just have to form a proportion. So let's just draw a tree real quick, give it some tree-looking stuff. Here's my random person here. We want to label things with some numbers here. So the height of my person, it says it's a 5-foot person. So there's 5 feet there. And he's standing near a tree and has a shadow of 12 feet long. Okay. And so we have this person shadow of 12 feet. Okay. Now we have this tree, and all we know about the tree is that it has a really long shadow of 42 feet long. Okay. And they're saying, what is the height? Okay. And so this is the part that I don't know is the height. And so you can sort of see, I'm going to outline it here. I hope you can sort of see this triangle that is formed here, and then the triangle that is formed here. Because the sun is hitting these at the same angle, we do have two similar triangles here, okay? And we're able to set up a proportion to find that missing side length, okay? So again, I'm gonna go ahead and set up my proportion of, I'm gonna use this 5 over 12, and then the x over 42, or you can do 12 over 5 and 42 over x. It doesn't matter as long as everything is placed in the correct position, okay? So let's go ahead and I'll say 5 feet over 12 feet, okay, is equivalent to, okay, and this is all, I just stuck with the boy on that side. So now I'm going to do the tree. And so I need to do, I'm actually going to put a little h here so I pay attention to its height and shadow. So now I have x feet of a height over 42 feet of a shadow. Okay, we can go ahead and cross multiply. I'm going to do my x first. And so I have my 12x equals 5 times 42. We have 210. Divide by 12, divided by 12. And you can see we have 17.5. So x equals 17.5 feet high. Okay. And so there we go. What is the height of the tree? We were able to use a proportion and solve for that. So that's what we're going to be doing with similar figures.